Good day, everyone. Today, we're going to talk about binary operation. Binary operation star on a set of real numbers is a rule which combines any two real numbers, x and y, and gives a real number. In other words, binary operation is a rule of combining two values to make another value. So what are these binary operation star? This can be addition, subtraction, multiplication, and division. Now, let's talk about the properties of binary operations, addition and multiplication. The first one is the closure property of a binary operation. The product and the sum of any two real numbers is also a real number. So for every real number x and y, their sum and product are also a real number. So for example, for the addition, x plus y is equals or produces a real number. A real number x plus a real number y produces or results to another real number. Suppose x is equals to 2 and y is equals to 3. 2 plus 3 results to a real number which is 5. Now for multiplication, we have x times y results to a real number. Suppose x is equals to 3 and y is equals to 4. 3 times 4 results to 12, which is a real number. So that is the closure property. Next is the commutativity of binary operations. A binary operation is commutative if changing the order of the operands does not change the result. Again, a binary operation is commutative if changing the order of the operands does not change the result. So for addition, for every real number x and y, x plus y is equal to y plus x. So changing the operands. So for multiplication, for every real number x and y, x times y is equal to y times x. So for example, for addition, for x plus y is equals to y plus x. Suppose x is equals to 1 and y is equals to 2. So changing the position of 1 and 2, so this becomes 2 plus 1, will not change the result. So 1 plus 2 is 3 and 2 plus 1 is 3. That is commutative. Now for multiplication, x times y is equal to y times x. Suppose x is 2 and y is 3. So changing the position of 2 and 3 will not affect the product. So the product will not be affected. So 2 times 3 is 6 and 3 times 2 is 6. So that is commutative property. Next is the associativity of binary operation. Addition and multiplication of any three real numbers is associative, meaning changing the parentheses or the groupings in any of the expression will not change the sum or the product. So for addition, for any real number x, y, and z, the sum of x and y plus z is equals to x plus the sum of y and z. For multiplication, for every real number x, y, and z, the product of xy times z is equal to x times the product of yz. So for example, for addition, so this is the groupings. So suppose x is equals to 1 and y is equals to 2 and z is equals to 3. So x is 1 plus 2 plus 3. So following the PEMDAS, perform the operation inside the parentheses first. 1 plus 2 is 3 plus 3. So 1 plus 2 plus 3 is 5. 3 plus 3 is 6 and 1 plus 5 is 6. So that is the associative property. Now for multiplication, so the groupings is x times y, or the product of x and y, times z is equal to x times the product of y and z. So suppose x is equals to 2 and y is equals to 3 and z, let's say, is equals to 4. So changing the groupings will not affect the product. So do the operation inside the parenthesis first. So this is 6 times 4 is equals to 2 times 3 times 4 is 12. 6 times 4 is 24 is equal to 2 times 12, which is also 24. So that is the associative property. Next is the distributive property of binary operation. So for every real number x, y, and z, so z times the sum or the difference of x and y is equal to the sum or the difference of the product of xz and yz. So for example, suppose we have this z is equals to 2 and let the x be x and the operation is addition and let y be y. So the distributive property, you're just going to distribute the 2 to the binomials. So 2 times x is equals to 2x and 2 times y is equals to 2y. Now using the real numbers, say z is equals to 2 and x is equals to 3 and y is equals to 4. So using the distributive property, just multiply 2 times 3 is equals to 6 and 2 times 4 is equals to 8. And 6 plus 8 is equals to 14. So that is the distributive property. Next is the identity element of binary operation. So for every real number x, x plus e is equals to e plus x is equals to x. So for multiplication, for every real number x, x times e is equals to e times x is equal to x. So for example, for addition, suppose x is equal to 2 and plus e is equals to e plus 2 is equals to 2. So what number are we going to add to 2 for us to get the sum of 2? That is 0. So meaning 0 is the identity element for addition. So another example, 3 plus e is equals to 3. So meaning e must be 0. So that when we add 3 to 0, it will give us the sum of 3. So any number added to 0 is itself. Now for multiplication, suppose x is equals to 2 times e is equals to e times 2 will give us 2. So what number are we going to multiply to 2 for us to have a product of 2? So that is 1. So 2 times 1 is equal to 1 times 2, which give us a product of 2. Meaning 1 is the identity element for multiplication. Next is the inverses of binary operations. So for addition, for every real number x and y, x plus y is equal to y plus x equals to the identity element. For multiplication, for every real number x and y, x times y is equal to y times x is equal to the identity element. We know that the identity element for addition is 0. Okay, and the identity element for multiplication is 1. So let's have an example for addition. X plus y is equals to y plus x, okay, is equal to e. So suppose x is equals to 2 plus y is equals to y plus 2 is equals to the identity element which is 0 for addition. So what number must be added to 2 to get the sum of 0? So that is negative 2, the opposite sign of the number. Okay, so we have now negative 2 plus 2 is equal to 0. So therefore, for addition, just get the opposite sign of the given. So another example, let's say we have 3 plus y is equal to 0. Or let's say this is negative. Okay, negative 3 plus y is equal to 0. So what number must be added to 3 to make it 0? So that is positive 3. Negative 3 plus 3 is equal to 0. So for addition, just get the opposite sign of the given. So how about for multiplication? So x times y is equal to y times x is equal to e. We know that the identity element for multiplication is 1. So this is equals to 1. So suppose our x is 2 times y is equals to y times 2 is equal to the identity element 1. So what number are we going to multiply to 2 to give us a product of 1? So that is just the inverse of 2 or the reciprocal of 2. That is 2 times 1 half is equal to 1 half times 2, which is equal to 1. Cancel this, that is 1. Cancel this, that is 1. So another example, suppose we have 3 over 4 times y is equal to the identity element, which is 1, is equal to e. So what value of y are we going to multiply to 3/4 to give us 1? So that is 3 over 4 times 4 over 3 is equal to 1. 3 divided by 3 is 1. 4 divided by 4 is 1. 1 divided by 1 is 1. So that is the inverses of binary operation. Thank you.